In this video, we're going to talk about the remainder theorem. To start off, let's think of some simple division. So how about, say, 12 divided by 3? Okay, well, of course, that's just 4, and it's just 4. There's no remainder, nothing left over. 12 divided by 3 divides evenly. Now, let's compare that with, say, something like maybe 12 divided by 5. Okay, well, this one is going to take a little bit more thought, so it does not divide evenly. Well, let's think about it. 5 times 2 is 10, so there's at least 2 5s in there, but there's not 3 full 5s, so there's some kind of remainder. So 2 times 5 is 10, and then we would need 2 more to get to that 12. Okay, so that's going to be 2 out of 5. So we have this remainder hanging out. So in this example, it divided evenly, meaning that there is a remainder of 0. And in this other example, it did not divide evenly, which means that there is a remainder of something else, which is the main thing that I want to talk about today. It's a remainder of not 0. And now we're going to talk about dividing polynomials and kind of how that fits in with the previous slide. So let's go ahead and take a look at this top example here, and they're actually both the same examples. We'll explain why in a second. Okay, but let's take a look at this top example right here. And what I notice is that I have an x minus 1 and an x minus 1 on the top and the bottom. And that means that those are going to cancel, and I would be left with just x plus 2. And since it divides evenly, there's nothing else to think about, the entire denominator is canceled, then that means it divides evenly, so there's no remainder or a remainder of 0. Okay, now let's go ahead and take a look at, say, the top versus the bottom. So when I look at x plus 2 times x minus 1, if I were to multiply that out, I would just get this, x squared plus x minus 2. Okay, so this top and bottom example are exactly the same. This is just multiplied out. So I know that it should divide evenly, and I should get a remainder of 0. Okay, here's where we're actually going to implement the remainder theorem. So here is what the remainder theorem does. It says if you take the thing you are dividing by, x squared plus x minus 2, and you plug in the opposite of this number on the bottom, so in this case, instead of -1, I would plug in 1. Another way to think about that same thing is maybe plug in what would make the bottom 0 or the divisor 0. So what would I plug in for x to make x minus 1 0? I would plug in 1. So what I'm going to do is for each of these x's here, I am going to plug in 1. So I'm going to plug in 1 here and 1 there, and then let's go ahead and see what I get. So plus and then minus 2. Okay, and here I get 1 squared plus 1, so that's 1 plus 1 minus 2. Okay, I guess I have 2 minus 2, and I get 0. And when I do that, what it tells me is what the remainder is going to be if I were to divide it. So I know that since I plugged it in, I get a remainder of 0. And so one more time, using that remainder theorem, what it says is I take the thing that I'm dividing by, so x squared plus x minus 2, okay, x squared plus x minus 2, and then I'm going to plug in maybe the 0 of my divisor. So what would make x minus 1 0? Well, 1. So 1 minus 1 would make a 0, so I'm going to plug in 1, or maybe the opposite of this number. So for everywhere I see an x, put a 1. Everywhere I see an x, put a 1. Okay, and when I complete that, I get 0, which means that the remainder is 0, which means that it should divide evenly. Okay, let's do another example here. And this time, I'm just going to go ahead and keep it in factored form. And when we take a look at this, so I have x plus 3 and x minus 2 on top, and I'm going to divide by x plus 4. So we can see that there's nothing that's going to cancel. There's not really a good way to simplify this. I cannot cancel any factors, which means that it's not going to divide evenly. So that means that the remainder is not 0. It's some other number because it doesn't divide evenly. Okay, so let's see if we can use the remainder theorem to figure out what the remainder is going to be. So I'm going to take that top thing, x plus 3, times x minus 2, and you could distribute it out. You could multiply it out. That would be fine. Or you could just keep it in factored form. That's also totally fine. And then what I want to do is plug in the 0 of the denominator. Okay, so what would make x plus 4 0? Well, what would make x plus 4 0? How about negative 4? Negative 4 plus 4 would be 0, okay? And again, that's kind of just like the opposite of this number right here. So plus 4, the opposite is negative 4. So the remainder says to plug in what would make that divisor 0 for anywhere I see an x. Okay, so here I have some x's. All right, so I'm going to go ahead and plug in those x's, negative 4 and negative 4. Okay, so here I have a x plus 3, or a negative 4 plus 3. Here I have a x minus 2, or a negative 4 minus 2. Okay, and then I have negative 4 plus 1, that's negative 1, and then times negative 6, and then I'm going to get out 6. And so the remainder theorem tells me that when I divide those, I will have a remainder of 6. And it's not a remainder of 0, which means it doesn't divide evenly, which makes sense because we could see that it didn't divide evenly. Okay, so I know I'm going to have a remainder of 6, and we could confirm this by actually doing that long polynomial division that we've reviewed in some previous videos. So here's another example. Let's say I want to take x cubed minus 2x squared plus 4x minus 6 and divide it by x minus 1. And maybe I just want to know if it goes into it evenly, or if it doesn't, what the remainder is. So using that remainder theorem, what I can do is I can just take that thing that I'm going to divide by, the x cubed minus 2x squared plus 4x minus 6, and then I'm going to take a look at that divisor of x minus 1, and let's think about what I should use according to that remainder theorem. So the remainder theorem says, well, take the opposite of the number after the x, or maybe what would make that divisor 0? So blank minus 1 would be 0. Well, that would be 1. So I'm going to take a 1, okay? And I'm going to go ahead and plug that in everywhere I see an x. So there's an x, there's an x, there's an x. Okay, and everywhere I see an x, I'm going to put a 1. 1, 1, 1. Okay, so that's going to be 1 cubed minus 2 times x squared, so 1 squared, plus 4 times 1, minus 6. Okay, so we have 1 cubed, 1. Okay, that's going to be 1 squared is 1, times negative 2 is negative 2, plus 4 times 1, minus 6. All right, here we have 1 minus 2. I guess I'll be in debt $1 right there. Plus 4 minus 6. Okay, I might think of that as 4 minus 1, which is 3 minus 6. Okay, if I have $3 and I subtract $6, then I would be left with negative $3. And that means I would have a remainder, when I divided that, of negative 3. And if you went through the entire polynomial long division, you would see the same thing, that you have a remainder of 3. But now we kind of have a fast way using this remainder theorem of finding out exactly what the remainder is, which also tells us immediately, or rather quickly at least, whether or not it divides it evenly.